In this video, we are going to discuss about form of gear tooth. So, traditionally, how that gear profile has been generated. So, initially, the meshing of one gear has been generated as an arbitrary profile. The meshing gear, second gear, they have been made as an generated, but it has to be satisfied that law of gearing. The law of gearing concept has been discussed in one more video. Okay. So, traditionally, the gear has been generated in this manner. So, while you are manufacturing the gear in this manner means it is very complex and tedious to manufacture also. Suppose any gear has been worn out means they have to be replace the gear. So, it is too difficult to replace. So, because of an complex in manufacturing of an gear profile. So, they have been come to one conclusion. So, in order to eradicate these olden methods. So, by using of this they have been decided the invention of an two profile gear profile which should satisfy that law of gearing has been identified and they may as an standardization gear tooth profile. So, what are they? Let me see. So, one is cycloidal gear profile and second one is called involute gear profile. So, let me discuss one by one. So, what does mean by cycloidal profile? So, generally the cycloidal profile, the cycloidal curve has been generated. So, when the circle has been rotated on the straight part without slipping, the curve which is traced, it is called as an cycloidal. So, under the cycloidal, so we can split two different curves. So, what are they? One is epicycloidal and another one is called hypocycloidal. So, let us discuss what is meant by epicycloidal and hypocycloidal. So, in the epicycloidal, how the curve has been generated is there are two circles with there. So, they have been taken as one of the circle has been fixed and one more circle is going to be rotate along the outer circumference of that circle. The curve generated, it is called as an epicycloidal curve. So, in a similar manner, let us discuss with hypocycloidal. So, how the hypocycloidal curve has been generated. So, in this we are having one circle, the inner circle has to be rotated around that outer circle. The curve has been traced, it is called as an hypocycloidal. Okay. How these two curves has been employed in a cycloidal gear profile? Let me see. Here I am shown that one of the cycloidal gear profile. Here the hypercycloidal gear profile has been used in the flank side of an gear tooth and the epicycloidal curve has been used in the face of the cycloidal. So, in this manner the cycloidal gear profile has been generated. Okay. Next we are going to see about involute. What is meant by involute profile? If in a circle has been fixed, if a straight line has been rotated along the circle or tangentially without slipping, the curve which is generated, it is called as an involute, or we can say the involute curve in this manner. So, if you take a rope and it is tied along the circumference of the circle, so if you unwound the rope means the curve which is generated, it is called as an involute. So, here I am showing the involute profile. So, these two profile has been used as an gear tooth profile and made standardized. So, only one more reason is that these two profile which should satisfy that law of gear. We are going to see the demonstration of an hypercycloidal. Here we are having two circles. The outer circle is going to be fixed and inner circle is going to be rotate around the circumference of the circle. The curve will be generated, it is called as an hypercycloidal. Let me see. This inner circle is going to be rotate along the outer circumference circle. So, without slipping, the curve will generate. Next, we are going to see the demonstration of an epicyclical curve. Here I am having the two circles. One circle is going to be fixed. Another circle is going to be rotate along the circumference of the fixed circle. The curve will be generated. It is called epicycloid. Let me see. The circle is going to be rotate along the fixed circle without slipping. Demonstration of a cycloidal profile with the help of an K. So, here the straight line is there. Now, I am going to roll this circle on the straight line, so without slip. Now, we are going to generate cycloidal curve. Let me see. So, the circle is going to be rotate on a straight line So I am going to have a curve அப்புறம் இது போட்டு